Hi and welcome back to MDriven Starter Course. We're gonna continue on chapter 4. So task number 106. Read a manifest on our view of what a line of business application needs. So I'm gonna look at that. So what it says here, getting to the bottom of the line of business application. And it states there are 3 kinds of forms and what the different modes are for the forms, etc. But the important thing is that for now, you should read all of this, but for next task, we know that there's a seek form that makes it possible to search things. And there's a document form. So if we go back here, the person view model from chapter 3 is a document form, because that's rooted in a person instance, and shows properties for the person. And now we will look at the seeker form. So we're going to find the outer form person seeker. Adopt this to make it your own. Now it's named person seeker. And we see that we have an action that takes us here, person seeker. So wait, we're going to make this seeker also search on H. In order to do that, we need to take this search string, check that it is convertible to an integer. The string 1 is convertible, but the string 1 with text is not. We can parse with the expression integer.parse and then the string. So we're going to start the debugger and try the expression. Verify you get an answer of 1. I'm going to copy this. And I already started the expression. I'm going to stop this just to show you how you get here, in case you forgot. So I can start the system and I can go for the debugger. So I get the result of 1. Check what happens if you do integer 1 with text instead. And it's empty. Get a blank result, yes. A blank result is a null result. Null is different from 0. It is nothing, not even 0. So we can check if the result is null with the is null operator. Integer parse 1 is null. And we get the checkbox back checked, so that's a boolean true. Verify that you get true. Test integer parse 10 is null. So that checkbox is not checked, so that value is false. And we're gonna do 1, 2, 3 and removing the is null. Pressing F5, F5 executes the yellow one. 1, 2, 3. Test integer parse v a new variable. Verify you get an error due to missing variable declaration. V a new variable is not a type name, so it doesn't understand. 113. In the top left box it says your variables. Enter VA new variable colon string with a big S. All types in OCL are expected to start with a capital letter. This is not a type, it's a variable name, but this is a type, string. And person was also a type, the class that we did earlier. Just gonna type this in this box, your variables, and I'm gonna end it with a enter. So now I'm gonna test this again. So now it's the error tab that's highlighted, OCL evaluated and v-result updated. So I'm going to switch back to the result, 456. That's the value that we entered as a string here. So this is the first assignment of the default value of this variable. So that was step 114. 115. Press the add expression button in the debugger to give you a new expression box. Select it. Note the yellow current marking in the right of the expression box. So add expression. Select it. This yellow one moved from here to here. So the yellow one is the one that will execute when we press execute. (116) Switch the lower empty expression box to action. Action is slightly different from OCL since action can actually change data. OCL can only watch data. Use it as input and output a transform result. So OCL can only watch data and use that data that it sees and transform it and send it back as output. It doesn't actually change the origin of the data, the original place of the data. So we're going to switch it to action. OCL, action. Switch it to action. 117. In the MDriven action language, there is an assign operator denoted by : equals. Test the assign operator by writing a new variable equals string 200. This. Execute. Note the output. Go back to the expression box with integer parse. Note the yellow marking changing. Execute and execute. Note that the output now is 200. So if I go here and integer parse a new variable, this is 200. So that's because the VA new variable now has changed its value from that one. Uh, 118. Go back to the expression box with integer parse a new variable. Note the yellow marking change. Execute. Okay, that was the one that we did. 119. Look in the top right hand box in the debugger. Here you will find your variable and its current value. Here. So I can resize this a bit. A new variable system string equals 200 currently. Also the v-result element, which is the automatically maintained variable called v-result element that has the value of 200, but that's the type of a system in 32, which is basically an integer. Hmm, 120. We now know how to assign a value to a variable. We also know how to assign values Yeah, I don't know what I meant there. We now know how to assign a value. Declare yet another variable in the top box. This one is gonna be called vInt holder, and it's gonna be of type integer, and it's gonna have the default value of 12, and with a new line. Okay, new line. And test vInt holder in the top expression box. 122. In the lower expression box that is set to action, try to assign the output to vInt holder by typing vInt holder assign integer parse vnew variable. So I'm going to try this one. So this is an action, and then we do execute. Check vInt holder value in top right box. That's a 200. Since both OCL and action language are functional languages, they act as function, and functions always return something. This something is always of a known type. We sometimes want to ignore the result of a function and instead perform another function and rely on that other function's output. For this purpose we have the action operator semicolon. So that's a action operator separator. Just a single semicolon. Let us try that in the action expression. Type vInt holder equals integer parse v a new variable, and then we have this semicolon, which means that this is ignored from the output, and instead we focus on this one, taking the new assigned value and add 1, and this will be the output of the whole function. And that will be 201. If we now check the int holder, we see that the int holder is still 200, but we add 1 just prior to returning the result. So the result element is 201. Okay, step 125. Switch back to the lower expression box. Switch back the lower expression box to OCL, execute, note the errors. This is due to the fact that OCL does not recognize the assignment operator, nor does it recognize the separate operator. These are only available in action language. Okay, I had a pause here, so I'm gonna start it over. Bugger. If I switch this over to OCL and press F5, it says undefined operation. If I go into the editor, it says this one is an undefined operation. If I were to remove that one, this one is an undefined operator. This is because these are only available in action language, and now we are OCL editor. So if I go back and switch this back to action and go into edit, I see that this is fine, and it says action editor. That's the main difference. Now that we know about separator and integer parse and assignment, we head back to person seeker. Right click columns, add new action column, place column in conflict free position. So in order to do that, I shut this down. I double click the person seeker here, right click here, add column, add action column. I'm gonna find a spot for that one over here, action column. Conflict-free position. And what I mean by that is if it was to be placed here, it's in conflict with the other one, so that's not good. 127. Note that the search string in the column named filter is assigned to a vSeek param variable. In the new button expression, since it is an action, we have action language in the expression. Write integer parse vSeek param. So note that this one, its value will be caught into the vSeek param. So whenever the user types in this box, it will end up in this vSeek param. But we were instructed to go to this one and enter the expression here to integer.parse vSeek param. Let's check that that's okay. Yes, that's okay. 128. Click the green box header person seeker. Note that the right side updates to show properties for this level of the view model tree. So when I press here, this part is updated to show properties that are valid for this. And as I click the different columns, this right side is updated. But we were instructed to press here and find the variables and validations button. Click it. Variables and validations. This is a full button, so we're going to click that. 129. Press add a variable, call it vSeek int value. Make it type integer. Skip initial value. Alright. So I'm going to add a new variable. Going to give it name vSeek int value. Going to be of type integer. Going to skip initial value. Let's save. 130. Head back to new button expression. Change it to vSeek initial value assign. All right, and leave the one that and what we had from before. So heading back to this new column, action column. I'm gonna go into the OCL editor. I'm gonna go first. vSeek int value assign the value from integer parse vSeek param. So this is okay. It will return type of system int 32, which is the same thing. This is the lower level C# type that represent an integer. So these are equivalent. Yes, it's good to use the OCL editor to help you find the correct syntax. So add yet another column, view model column. Choose generic view model column. Place the text box near the button. So I'm going here, add column, add generic column. So I'm going to place that near here. So action column, new column. Set the expression of the new column to vSeek int value. Okay, so the expression of this one should be this. Save. Go to web application, Opera Seeker, try to find 123 in filter box. Try to write 123 in filter box. Press your new button. Check the new column you added shouldn't show 123. Let's start things up here. I think it's already running. I'm going to switch to the browser. I haven't tested this yet. I'm going to find the person seeker. It's up here. Since we adopted it, it got its own action without the autoforms stuff on it. Brings up the seeker. We see our button and this column here. I'm going to write 123 and press this one. And this says 123. Good. write some text in the filter, press your new button, check the result in new column. It should now be null. Okay, text. No, it's null. So 135. We're now going to put this initiation of the integer value into the main search button. We do this by adding vseek int value equals or assigned to the outcome of integer.parse vseek param before the current search expression. So I'm going to copy this. But in order to hold the two expressions apart, we must use the semicolon separator. So this might sound more difficult than what it is. We're going to go here and going to paste that in. And since this is not understood currently because it sort of is not a valid function, we need to use the separator operator semicolon. Now it's valid. And what I'm going to do is, for increased readability, put this last line on its own line in OCL. So that's no problem. Or now I said OCL, but it's the action language. So what we do is we parse the incoming as if it was an integer, the integer value will end up here. If it wasn't an integer, this will be null. And this one is appended with the seek param and two percentage signs. I'm going to come back to what those mean, but essentially there are wildcard signs for OCL persistent storage search. And finally, it will call a function of the self VM variable, which is unique to each view model. So self view model search, and the search will trigger search functionality using search expressions in your view model and populate vSeek result. So the search expressions are these orange ones. We're gonna come to that just now, but now we did this one. 135. Open up the action editor. Bam, bam, bam. Use just for ease of reading. We're gonna put a new line. We did that. 36. 136. We have now a strongly typed integer value in vseek int value, and we will use this to compare to age in the search criteria. So the orange view model classes in the view model are called search expressions. A search expression uses the third and last type of language in MDriven. We call this language OCL PS. So PS is short for persistent storage, and that would be the database, the persistent storage. So OCL PS is important to large enterprise application that may have many millions of person objects. So we can use OCL for this, but it will not be as fast as if we instead meet the database halfway and talk to it in its own language. The language of the database is different depending on type and brand of the database. Most large production-grade databases use a proprietary dialect of SQL. Since MDriven wants to work no matter what, we use OCL PS that is then translated to the correct SQL or other database language. So 137. Select view model class for seeker expression, orange, called seek criteria. Select criteria 1. Within it, change the expression from person all instances to person all instances select. And then we have P as a loop variable and a pipe sign to denote that this was the definition of the loop variable, what we're going to call each object passing through this select operator. and dot age equals vseek int value. So we're going to copy this and check this one, and we should select the seek criteria and the criteria within, which currently is just person, all instances, which will match all the rows in the database. A seeker is default, it will limit the number of max values that you can expect in return, just because it might be millions and then you don't want to make your application hang and wait for those millions to load. It's more beneficial to just show the 200 first or 100 first or something like that. So I'm going to paste that one in. So person all instances select, so P is a loop variable, and P each person object that comes in here, we're going to check its age, and we're going to compare that with our integer value, and if that is true, it will pop out the other end, so the result will be a collection of persons. In our case, it will be a collection of persons that match this age. So saving and check web. So I'm going back to web application. Okay, maybe I have been showing you a much too wide screen here because I didn't respect the screen size. Let's see. Now you see it anyway. So when I search, if I search for nothing, I get 2 people back. Let's see what happens if I put 10 here. Search. So I get nothing. Why is that? Also, I would have expected to get 10 over here, right? Because when I have added 10 here and press search, so I'm going to check what's up with that. So this one is still there, so I'm gonna check what happens if I press this one. Then it says 10, of course, and if I were to remove that and press this one, it doesn't seem to have recognized my updated. I'm gonna refresh this one. Right, 10. So now at least it shows 10 up here, which is good. So let's figure out what's wrong with this, and I suspect that going to this criteria here, we also see that we have an active expression. So the active expression says vseek param is null or empty. So what active means that this will only come into play if this evaluates to true. So currently, since we made a change to it, it probably made sense on the old expression, but on the new expression it doesn't make sense. So actually what would make more sense is if, well, actually I'm going to remove it completely, because then it will always be active. So I'm going to do a item of this, 138. Remove the active expression of create one to make our new seek expression have an effect. I'm going to save this and heading back to here, and if I write 10 here, I found this guy that's 10 years old, so that's fine. If I were to write 11, there's no one that's 11 years old. If I clean this out and press, I see I only get one person. And why is it that I get this one person? Well, probably because now we think that the age is null, and this one has age null, so it matches that one. That's fine. So if I search on, let's do a new person. That's 12 years old, and call him 12. And head back here. And we search, and if we search for 12, we will find this person 12. And also if we search on the age of, let's search for 11 first, nothing, and 12, search. 139. Change the expression to person, all instances select pH larger than vseek int value in order to search older than, save the test. So I'm going to go here and do this larger than, so the age, did I write it that way? In order to search older or equal, yeah, to search older than, yeah. So age must be bigger than this value. Okay, say heading over to web and search. So if I search on 8, I get 2 persons, but if I search on 10, I only get 1 because there's only one that's older than 10. Change the expression to larger or equal in order to search older or equal. Okay. So saving and search on 10 again. Do a refresh here. 10, come on. Yeah, maybe I didn't leave this field, so when I saved it was still wrong. So I'm gonna do it again. 10. Search. So now I get 10 and 12. If it would say 9. Yeah, because these are older than 9, obviously. I meant if I said 13. If I said 12. If I said 11. Enter the active expression to vseek int value not null to make this expression active only when we have a number. Save and test. This one, active expression, I can go into, see this is OCL, not OCL PS, so this is evaluated prior to us actually trying to talk to the database. So this should be not null in order to be active. And we're going to test. And if there's a, so that expression isn't active at all when this is not a number. That means that we'll get hit on the first expression instead, which does the wildcard search on the name, and that's fair. Search for anyone starting with Hans, and if I do like this, still get a hit. So what the search logic will do actually, if yeah, we'll come to that. So we have the active expression there. 142, remove new column and action column. They only helped us. They fill no function now. So I'll go here and I can either drop it here, delete column, or I can stand on a widget here and do delete widget. And that's the same effect. Save it. So these are gone now. Search, search. Mm. 143. Create a person that is called 123 and is 456 years old. Let's turn this around because I think so let's make him, call him 456 and that he's 123 years old. Yes. So new person that's 123 years old and his name is 456. So this is a trick question because his name is actually a string, but it can be interpreted as a integer, of course. So heading back here, search for 456. Right, now we got a hit on the name 456. Well, actually, I think I did it wrong anyway. It should be the other way around. It should be that I'm gonna do show person here and say that the age is, or the name is 123 and the age is 456. And I'm gonna go back here and 123 456. Search for 123. It's gonna search for 123. Search, and now we got a hit on the name. This name is actually called 123. But how should I show this to make sense? Let's create yet another person that's 130 years old. So maybe I should have thought about this before. Guy 5, let's call him that. I'm gonna search for 123, and the first time I searched for 123 I got a hit on the name. This, if I without any changes, press search again, think about the result. Yeah, so that was the point really. 144. Create yet another person named guy number 25 and make him 130 years old. So suppose I'm a person that has entered something completely nonsense in here. There's no hits, and then I enter 1, 2, 3 and I search and I get one result for the person's name, but I'm not happy with that because I was actually hunting for people with a certain age. So then I would just press search one more time, and now we search on the age, and then both these persons fill up the criteria. This has to do with the order of these search criterias, and 145, read the section on seeking the database with OCLPS. Pay special attention to the section marked with number 4 and batches of search expressions. So it's this page. And special attention to this section. So if we just go over it here, the second batch of search expressions is executed the second time the user clicks the search button, but only if the search variables has not changed. So how this logic works is that it first tries to do this one, and if there's a result, it's fine. It pauses there and shows the result. But if there's no other changes and the user press search again, we ignore this one because you don't want to do the exactly same search once more, and we go for this instead. So that's a way to pack multiple searches into one simple button. Also, if the user searches and there are no results from this first batch, then the second batch is attacked immediately, and then you might get results here. And we would see that by searching for not 1, 2, 3, but 1, 2, 2. Then we get these two guys immediately. And searching for 1, 2, 3 will only give the first one because that's a match on the name. And if we want to make this clearer, we could do, yeah. So I think we call it a night there. Good. Moving on, and see you in the next session.